right into it. Greetings and welcome. This is Coding and Science Activities for Hour of Code. We hope to show you over the next hour some activities for specifically across the grade levels of complexity and levels of equipment, some things you might be able to do in a science class for coding next week during the Computer Science Education Week. So a couple of housekeeping notes before we dive into the content. Your microphone is muted. The four of us presenters will be taking turns speaking today, but we want to make sure that we don't have too much noise, but we welcome your questions in the chat. Here's a little bit about the chat window in GoToTraining. It's going to vary in its looks depending on what platform you're on. Here's a screenshot from Windows. You may see something like this. What I want you to look for is a little chat panel within this set of tools. You may need to twirl it open to gain access to it. When you do, you'll see there are places for typing messages and a place to select who you're sending it to. Today, we encourage you to send most of your messages to everybody, but if you have a question just for the organizers that you don't want everybody to see, perhaps you want us to address it individually, please send it to the organizers. We're going to be tag teaming, so we want to make sure that all four of us organizers have the opportunity to answer it appropriately while the others are presenting. You may find that you need to collapse this panel. On Windows, at least, there's an orange button here that will let you collapse and expand it. But go ahead and open it up, find that chat panel, and let us know you found it by sending a chat, letting us know where you're calling in from today. Joseph, welcome from New Jersey. Katarzyna, Warsaw, great. Karen from New Hampshire, Heather, Virginia, Rachel, Illinois, Dan, it's like you're in the next room. Umberto from Lisbon, welcome. Obrigado. Steve, Minnesota, fantastic. Chile, New Jersey. Great, well, we're delighted you can join us today. And please be active in that chat panel. We'll be monitoring it for your comments and any questions that you have. So if you are watching the live session as opposed to the recording, you'll see that as example right now, we have one camera on. It's a picture of my head right now. And we also are screen sharing, in this case, some slides that I have. In the live session and the live session only, you do have control over the relative size of that. So if you want to see more detail in the physical thing, when we actually show something interesting, perhaps, you can expand and collapse the size of the relative size of the video and the screen sharing. Each of those may be going on or off today as we vary what we're showing you, but you do have control over that in the live session. Speaking of recordings, this is being recorded and you'll get a link to the session tomorrow. It's going to be posted unlisted on YouTube, but that means you can share it and use all of YouTube's great tools. I mentioned to those of you who joined us early, there's a lot of content today. We're going to go through things very rapidly. So if you want to do some of these activities, look to the recording as a place to learn more about them, slow it down, maybe walk through it yourself, or even use with your students. We will be putting links to each of the four starting sections for the four activities today. If you wish to jump directly to those, you'll find that in the description and the YouTube movie once it's posted. We're also going to share with you a lot of assets, from PowerPoints to student-ready files, instructions, and SparkView and Capstone files. You will find all of those here in a Dropbox folder. I'm going to put this link directly in the chat, where it'll be a live link you can jump to. You're going to see its organization is basically a set of generic resources across all of the activities, and then a folder for each of the four activities that we're going to show you today. So please use those resources. So a little bit of Hour of Code. You may or may not know about Hour of Code. You probably do if you're joining this session. But Hour of Code is an initiative by various technology companies to engage students and teachers in a little bit of computer science experience each year. It's timed for the next week, which is Computer Science Education Week, December 7th through 13th, which coincides with pioneering programmer Grace Hopper's birthday on December 9th, I believe. But the idea is to demystify code, get students exposed, and get a greater diversity of students exposed to coding experiences. Now, we're not directly associated with Hour of Code, but there's some great resources there. We hope to show you some coding things that you can do with Pasco software, even if you have no Pasco hardware. And if you do, some additional things you can do with that. But we hope you'll find some opportunity to engage your science students with the Hour of Code next week. So we'd love to know a little bit about your experience level with coding. So I'm going to launch a poll, and in a moment your screen should switch over and you'll see that we'd love to know which of these best describes your experience with coding. Are you new to it, or is it mostly new to you? Do you have some experience yourself with coding, or do you have some experience and have also done so with students? So we'll leave that open for a few seconds to give you the opportunity to respond. Most of you have already responded. Thank you very much. Maybe 10 more seconds. Fantastic. So let me close that poll and I'm going to share the results with you. So we can see the majority are new or mostly new to coding. Great. We're going to jump in with the first activity here, which shows you the fundamentals of what you need to do with Blockly code inside of our software, even in the free version of SparkView that can be available on phones. Just over 20% have some experience, and 1 in 5 of you has also had some personal experience and brought that over to the classroom. So especially that last group, if you have some experiences to share, some advice, please share them with everybody in the chat. We welcome your experiences with students, and I think we'd all benefit from that. So let me hide that poll. Thank you for your responses. So I'd like all 4 of the presenters right now to turn their cameras on, and I want to make sure you can associate faces with names here and voices, most importantly. So you can see the 4 of us are here. We are delighted you can join us. My name is Glenn Starkey. All of us are in the Pasco Curriculum and Professional Development. I think we'll give each of us a chance for you to hear a voice and maybe let us know what your specialty is here in our department. Heidi?
Hi, I'm Heidi Brennan. I am the K-8 specialist here at Pasco.
Barbara?
Hi, I'm Barbara. I work with biology and chemistry at Pasco.
Fantastic. Dan?
And I'm Dan, and I'm the physics curriculum and training specialist here at Pasco.
Great. Thanks so much. And this order of introduction is the order in which we're going to present our 4 activities today. So here's kind of a synopsis of those activities. I want you to mainly get out of this that it's going to be over the entire range from blocky basics to adding a little bit to that with Heidi's compound conditionals and physical outputs. Barbara's going to add a lot of options in the code, and Dan's kind of going to take it and put it in a fairly complex thing that's probably an AP level or college level. So you're going to see a whole range of features. You're going to see a range of equipment as well, but we want to make sure that even if you have no Pasco equipment, your students can do an activity with the free version of SparkView available on phones. So the first activity that I'm going to do is going to introduce you to the fundamentals of using Blockly and our SparkView software. And we're going to see examples throughout of additional hardware like the code node from Heidi, temperature sensor for a neat activity from Barbara, and physics-centric rotary motion sensor or photogate and pulley from Dan. You'll notice that each of us is going to use a piece of software, and the first 3 of us are going to use what's called SparkView. Dan is going to focus on Pasco Capstone. A little bit about the software difference between this. Pasco has 2 general purpose applications for collecting and analyzing data, primarily from sensors. The first is SparkView. SparkView is available on Windows and Mac, and it's available as a free trial. We have a half-year free trial under the current circumstances, so it can get you probably through the rest of the Northern Hemisphere academic year. Licenses are available, but the one thing I want to focus on is that SparkView is completely free. The full featured version of SparkView is free on your students' phones, whether it's iOS or Android, and on Chrome OS, so the Chromebooks that many schools are adopting. So the first activity is going to focus on what can you do with a phone using the free version of SparkView. Capstone's available on Windows and Mac, also a free trial. Check it out, the free trial if you don't have it already. Both are general purpose data collection and analysis. SparkView focuses on all sciences from elementary school through early university. Capstone has features that are focused primarily on physics and engineering, especially in the upper high school through upper university levels. The key thing for today, though, is the same Blockly coding is available and behaves the same in both SparkView and Capstone. So if you see something that we're doing in SparkView and say, but I use Capstone, you'll be able to translate that. And in fact, you can even open the SparkView file in Capstone and the code will come over with it. So don't be constrained in thinking that the software that we're showing in any particular example is key to the use of Blockly coding. What we're going to show you generally applies to both today, with the exception of the first activity, which is going to be phone-centric and SparkView-centric because of the free version of SparkView on the phone. If you want to learn more about the comparison of these 2 pieces of software, we have a link, and all these links are in the slides that we're going to share with you in the resources. So I would like to jump in here to the first activity, and the focus here is on the Blockly basics. What can we do with code? And fundamentally, we're going to take inputs from a phone's built-in sensors, no Pasco equipment needed. We're going to take a look at those inputs, and we're going to have some sort of output. So it's an input, coding, and output. And the specific topic I'd like to look at is phone orientation. So I have my iPhone here running SparkView. This works just as well on Android. And you'll notice, as all of you and your students have experience with, if you rotate the phone, the application follows it so that it's always upright if you're looking at the live camera view here. So what I'd like to do is take a look at how does a phone do that? So you might also consider this the turn that frown upside down activity. So I'm going to bring up a projection of my iPhone so that you can see the details. So let me begin mirroring that, and I'll bring it on screen. And as I do that, think about how do you think it's possible that this phone is responding to the orientation? What sort of sensors are being used? What features are being used to allow that? Now, before I actually jump into the activity, you can see SparkView here, and you can see as I rotate the physical phone, we get a view changing there in my projected view as well. However, I don't want the phone to be doing this. I want to be doing this myself, so I am going to turn on the rotation locking feature on my iPhone so that now when I flip it upside down, it no longer rotates, because I want to figure out how to code that behavior myself. So taking a look here at the phone, the first thing we need to think about is, well, what inputs are available? What possibly could be indicating to the phone or to our code in SparkView how the phone is currently oriented? So I'd like to talk briefly about the sensors available inside the smartphone that SparkView has access to. Now, it differs a little bit on iPhone versus Android, but fundamentally you have two sensors that are always available on all the Android and iOS phones I've looked at, an onboard acceleration sensor and a microphone. Many Android phones also add to that some neat capabilities to access light sensors and GPS sensors, but I'm going to focus today on using the acceleration sensor that's available across all the phones that I've checked. So let me show you how to get information from that acceleration sensor. If you look here at my shared iPhone screen, I'm going to tap on the center button called Sensor Data, and it's going to show us what sensors are available. Again, we're focusing on sensors that are built into the phone, so no Pasco equipment needed. You'll notice my iPhone has both acceleration and microphones. I'm going to turn on, by hitting that little switch, the onboard acceleration sensor, and it turns out I have 4 different measurements I can get from it. I'm going to turn off the resultant because I don't really know which of the 4 axes of acceleration, X, Y, and Z, that I want to use for my little code that's going to monitor the flipping. So I'm going to turn on X, Y, and Z accelerations, and I'm just going to choose on the right side the template that says graph, because I want to get some data to try to make a decision, perhaps with your help, about which of these would indicate the phone is being flipped in the way that I showed in the live video. So we get a graph that has 3 accelerations, plots of X, Y, and Z acceleration from top to bottom. And if I hit that green start button at the bottom while I'm holding the phone upright, I'm going to define this as upright with the home button on the right side from your view. I'm going to hit start, and let's take a look at these measurements. We're getting live plots of X, Y, and Z acceleration. I'm going to rotate the phone around 180 degrees like that, and then I'm going to rotate it back. So from upright to upside down and then back, and I'm going to press the stop button on the phone. And I'd like you to look at those 3 acceleration measurements, either X, Y, Z, so different directions of acceleration. And if you had to write some code or interpret these, which do you think is easiest to interpret, even in English? Which one of these allows you to say, you know what, I can define a rule that says if this acceleration does this, then it's right side up, and if the acceleration does that, the phone is upside down. So I welcome your ideas in chat. Which of these accelerations from top to bottom, X, Y, or Z, provides the clearest relationship with that rotation that I just executed from landscape upright to landscape upside down? So from top to bottom, they are X, Y, and Z. All right, Mary says Y. Okay, yep, notice those 2 humps here. Any other thoughts? Thanks, Mary, for your input. And this is the neat thing about coding. We are essentially, we could have this conversation without code, but we're going to find that coding allows us to, requires us to be pretty comprehensive about this. So imagine if we ask Mary why, well, there are some 2 humps there that show when I was rotating it. We see some other things. Connie says Z, David agrees Y, Choi says Y, Karen says X. Yeah, so a lot of options here. We don't have a lot of time, but this would be a great opportunity to talk with your students. Maybe ask your students, could you write down in English on a piece of paper or in a text document here, what rule you would describe in English? If you just had to tell someone, I can look at graph of X, Y, or Z and tell you if the phone was upside down or right side up. And I think I would have the easiest time with X, the top one, because if we look at it, I have a range here from about -10. The units are a little obscured here. We can open it up on a larger screen, but this is acceleration in meters per second squared. And I'm going from -10 when the phone was upside down to +10 when it, I'm sorry, right side up was -10, upside down for my phone was +10, and then down to -10. There are definitely 2 humps here, but I think in English I could describe more easily that, you know what, when it's negative, it's right side up. When it's positive, it's upside down. Yep, David noted that the legend itself here says Y1, Y2, so I misinterpreted his thing there. So Y1 is indeed X. So we can think of that. All of these could, in theory, be coded, but I want to take the easy route here for this initial thing. And I want to consider that rule in English, that the acceleration in X, when it's negative, my particular phone with its orientation of sensors is right side up. And when it flips, the X acceleration is upside down, is positive rather. So how do I access code? Well, first let me build a new page where my code results are going to be. To build a new page, I'm going to hit this plus button in the upper left, and I get to design a page. I'm going to scroll down and pick something that has two items here, a left and a right, that are about the same size. And I'm going to fill each of them with a digits display, which is that 1, 2, 3 button. And on the left one, I'm going to choose select measurement, that orange button. I'm going to say acceleration X because that's the one I want to code. If your students, if you want your students to explore, they could try the others as well. So I'm going to try acceleration X. I'm going to leave that right-hand digits display blank here because that's going to be my output of my code. We're going to come back to that later. How do I access code in SparkView? Well, there is a code button in the lower right there. I'm going to tap on it, and it's going to open up our view of code. So you're going to notice along the left side, I have some categories, and if I click on any of them, say logic, you're going to see it opens up a little tray of blocks. And this is a block-based programming language, as the name Blockly would imply. I can drag out these blocks. I'm going to drag out the if-do block into the center here, and to give you a better view, I'm going to pinch and zoom so I can magnify that a little bit. So I basically want to make a decision. If that acceleration is negative, it's upright, and if it's positive, it's upside down. So I have this if statement. That's a great way to make a decision based on measurements. Well, how do I get the measurement? I'm going to go under hardware, and those same measurements that we saw on the sensor measurement screen are available. So I'm going to drag out acceleration, and you may say, wait, I wasn't interested in the resultants, but if I click on acceleration resultant, you can see I can choose any of the measurements available from that built-in sensor. So I'm going to choose acceleration X in meters per second. Well, how does the if statement work? If I were on a computer, I could actually hover over this and it would tell me a little tooltip, and it says, if something is true, then do some statements. So I need to put something after this if block here that is true, and we'll execute the statements there. Well, I've already said in English, well, if the acceleration is negative, I want it to declare upright. So I'm going to return to the blocks on the left, and I need to do some sort of comparison that will result in a true. Something you could do is something equal to or greater than. So I'm going to drag out this block. It's a comparison operator. It starts with equal, but I can click on that little drop down and say, you know what? When my acceleration is less than, and I'm going to drag on the left side here and drop that value of acceleration X in meters per second squared. So you can see this block-based language allows students to get away from the problems of little syntax with spaces, because you can drop things in. If they don't belong there, they won't fit. So I'm going to say I want it to be less than 0 to be negative. So I'm going to return to the math blocks here, and I'm going to drag out this number. It starts as 1, 2, 3, but I can simply tap in it and change that to 0. And I now have a statement that says, hey, if I click that in, if the value of acceleration in X is less than 0, that is, it's negative, do something. What's the something I want to do? Well, we need to figure out about what are the outputs that I have built into SparkView. So we've talked about inputs. Outputs, we have two options within SparkView itself. We can either output a sort of message in the form of text that can be displayed in a digits display or a table, or numerical, which can also be displayed in digits, table, meters, even graphs. And you're going to see some examples, especially from Barbara, of those other numerical outputs. So I'm going to choose a text output. I want some sort of message to come out here. So let's return here. Where do I get code outputs? Well, they're in the code output tray. I'm going to tap on create text output. And this is not the output itself, the message itself. It doesn't say upside down right now. This is the name of the category of things that could vary. So I'm going to say, I'm going to create a message, and I'm going to drop that in. So whenever the acceleration is negative, I want the message to be, well, I could come in here and type upside down. But do kids still use emojis these days? If they do, I thought it might be kind of neat to put in a right side up face and actually just have this do the flipping itself. So I'm going to have a right side up face that as the smile will be right side up if the phone has the correct orientation. Well, what if it doesn't? What if I flip the phone over? In that case, I want something else to happen. How do I access else? Well, I'm not going to find it in the logic here. It is built into the if statement. So if I hit that gear to the left of the word if, I can choose to add as many else or else if statements that I'd like. And if I tap the gear again, it closes. So I now have an else statement. If the value is positive, I want something else to happen. Instead of doing the text output again, I'm going to use a nice little trick here. I would right click on a computer or on the phone. I'm going to tap and hold, and you notice I get a little menu that pops up, and I can duplicate that statement And in this case, the phone will be upside down. So I want the face to be upside down, and there happens to be an emoji of an upside down face. So my hope is when this works, it's going to always be an upright face no matter the orientation of my phone. Well, let's see if it works. I'm going to exit the code by tapping on that green code button in the lower right. And the orange select measurement up here, I need to define this as my message, the text output. So I'm going to tap on that. I don't see message here under sensors tab. So I'm going to tap on user entered and I get a message. And in order to start running my code and my sensor measurements, I need to press that green start button as we saw on the previous page. So I'm going to press it and let's analyze what happens. I'll do this so you can see both the live phone and screen. All right, that's looking good. I flip my phone over. Uh-oh, nothing's happening. So one of the key things in my limited experience in coding is nothing ever works the first time. All right, so troubleshooting is something that programmers need to do all the time. Can you help me troubleshoot this problem? If you have any SparkView experience, notice what happened. I pressed start. Did anything happen? I pressed start, the code executed, and So this brings us to the topic of, Ricardo says something intriguing there, make a loop. So let's talk about what Ricardo is suggesting there. We now need to talk about something crucial in programming, and it's program flow. So let's think about the thing that we're doing so far. It's almost as if we're coming to two roads diverging in a yellow wood, all right? And to start the code execution, we hit the start button in SparkView, and we had a decision made. We had a decision to make. All right, if the acceleration's negative, do this. If it's positive, do that. So it's almost like we're choosing which path with that if statement, which path to go down. But as Ricardo noted, you know what? As soon as that code is executed, SparkView says, oh, no more code. I'm going to stop. So it stopped automatically. So what do we need to do? Well, Robert Frost gave us a hint here, highlighted in lower right. I doubted if I should ever come back. So as Ricardo suggests in the chat, we need to make this happen again and again and again so that it is analyzing this if statement repeatedly. As long as we want it to, as long as we are rotating the phone, we want it to respond. How do we do that? Well, we're going to make a loop. We're going to go down the path, make a decision, then say, oh, let's make that decision again. Let's go back to that if statement. We can do that through a loop, and one of the ways to do that is to have a repeat while true loop. In other programming languages, Scratch and so forth, you may find forever loops. Repeat while true is equal to a forever loop because repeat while something is true, while true is always true. So let's try to implement that in our code. Returning to SparkView, I'm going to go back to the code. The repeat loop is under loop here, so I'm going to choose repeat while, and I can just drop it here, and it encapsulates all of those, and I just need to say, I want this always to happen when the code is running. So I'm going to go under logic, and true is always true. Oh, excuse me. I'm going to drop true in here. All right, and let's see if that fixed my code. So exiting the code, I'm going to press start again. All right, it's working there upright. Good news, I can see the acceleration still being measured, so let me rotate it over here. You can't see it very well on the screen, but go ahead and look at the live video, and you're gonna notice that I'm essentially figuring out that if I always want a smiley face, no matter which way my phone is oriented, the code that I've just created allows me to do that. All right, so let me hit stop. All right, so this is the final code. Pretty straightforward, but I think whether you have experience coding or not, especially if you don't have experience coding, you can see how many concepts we're able to get just to have something kind of neat. In this example, I think it's kind of neat to figure out how some technology works. And the phone is essentially little bits of code, little clevernesses built upon each other and standing on the shoulders of giants. And that's a neat thing that you can convey to your students during the hour of code. I need to jump to the next presenter, but I want to show you that there are many things you can do with the sensors built into the phone, whether it's an iPhone with acceleration and sound level or an Android that might add lighter GPS. Here's a list of ideas. I will leave this up for a moment as Heidi prepares to present her next activity, which is going to be about sound levels. But this slide and all the slides are in the assets here. And if you have any additional ideas, some things you've done with any of these sensors or additional ideas, please do share them. Lots of neat things to explore. You might also think of extensions. Heidi, as you get ready, I asked my son last night, and he said he'd like to make the face go sick after 10 flips. That introduces a lot of neat new coding concepts for that simple extension. So let me switch it over to Heidi.
Hi, everybody. Thanks so much for joining us today. All right, perfect. Let me get this clean for you guys. I got my presentation shown in 2 spots here, so let me get to the right screen. Excellent. Okay, so Glenn, thank you very much for that. He showed us how to get started, the importance of loops, conditionals, and then compounds is what I'm going to move to next. So you saw how to use onboard sensors with Blockly. So now we're going to talk about using onboard sensors with our code node. The code node is a really interesting device because it has several inputs. On this, we have sound, we have light, we have an accelerometer, we even have a magnetic field sensor and an ambient temperature sensor as inputs where we could be collecting data. When you saw Glenn's examples, he gave us the outputs in Blockly, which are text, numerical, and emojis, which is pretty awesome. I love that you can put emojis as your output. The code node has some additional outputs, things that you can program. We have an RGB LED, red, green, blue light, great for color mixing. We have a 5x5 LED array that you can program, and then we also have a speaker, also again with the numerical text and emojis. So you might have covered sound in the classroom. So students are understanding amplitude and pitch of a wave, and that amplitude determines the loudness. A softer amplitude, softer sound, a higher wave on that amplitude, a louder sound. And we measure, oops, jumped a little too quick there. We measure sound in decibels. And I have this chart up here because it's really interesting for students to see what sounds make at certain decibels. So a whisper is only going to be 30 decibels, where a normal conversation, you've moved up to 60 decibels. And these are interesting and important things to share with students because when sounds get too loud over an extended period of time, you can actually cause some hearing damage. What brings this in the classroom even more is now let's talk about this. Let's solve a problem. What's something that a lot of students have access to? We have cell phones and earbuds, and how many of you out there have heard the sounds radiating from your student or children's earbuds? You know that that's too loud and they shouldn't be listening to that. Well, the code node itself doesn't measure sound in decibels, but it measures in loudness from 0 to 100%. And it is a safe range from 15 to 35% loudness to listen to earbuds. So could we use the code node and our understanding of sound to create a program that lets us know when we're hitting dangerous levels with our earbuds? Let's give it a shot. All right, I'm going to switch my webcam view here very quickly because I want you to get a better view of the code node. Okay, let's make sure you got this guy centered. Let's clean up that focus just a little bit. And now I'm going to direct you to SparkView. Let me try that one more time. Oh, perfect. Thank you. All right. So first things first, I'm going to turn on my code node. And you see the personality come to life as it winks at you. And I'm going to choose sensor data from Blockly. I'm going to connect my code node to my computer. And Glenn showed you before the view when you were using Blockly with your onboard sensors on your cell phone. And you saw where if you have an Android, your light sensor accelerometer showed up. Well, this is showing you all of the inputs that are available on the code node. Again, we have ambient temperature, light sensor, and loudness, magnetic field strength. We have the accelerometer, the motion sensor built in here. And then we also have these 2 buttons or switches that you can also program. For this example, since we're focusing on sound, I'm only going to select loudness and disable the other sensors and choose the line graph. I'm also going to prep my cell phone here and bring up some music because it's really important before we build the code. We need some data. We need to be able to understand what we're looking at. So before we build the code, let's just run this with sound. And I'm going to just literally take my earbuds and I'm going to put it right over the ear icon here for my sound sensor. And let's see what happens as I increase the volume of the music on my cell phone. We're just looking at the data at this point, the graph. So as I increase the volume, the sound level goes up. I got all the way up to 100 there. Now I'm turning it all the way down to mute. Pretty interesting. All right, so let's stop collecting data and create a code that lets us know the different ranges we're hitting where it's safe to be using these earbuds. All right, here we go. I've got to move this over for myself. All right, so first I'm going to start with a loop. Again, this is so the program runs continuously until I tell it to stop or give it another condition. It will be repeat while true. Then I need to bring in my logic block. And let's create the conditional statements. All right, I'm going to bring out this very large comparison block, and I'm going to build what we call a range. So remember at the beginning when we were talking, I stated that in terms of safety, 15 to 35% is the safe range to be listening with your earbuds in terms of how the code node registers sound, again, from 0 to 100. So I'm going to give it a range here. I'm going to click on hardware, and you see all of these things that are highlighted. These are the inputs and outputs that are available for you when you're coding with the code node. I'm going to bring this first one in, and you notice it says brightness. Just click the arrow, and I can choose loudness. Now I could pull that block out again, or I could right click it to duplicate it to make my coding move a little bit faster. I need to pull in my math blocks. All right, so let's start our first range. If the sound level is greater than 0, and let's say less than or equal to, let's do 14%. I'm going to say this is a really safe range. So what do I want my outputs to be on the code node? Let's have some fun with this. So if I'm 0 to 14, I'm going to have the LED array just illuminate that middle right there. And let's add something else. I want, oh, I'm having a pause here. Give it a second to catch up. There we go. All right, and I also want to add my RGB LED. So right now it has all these 3 colors illuminated at an intensity of 5. If I left it there, I would have a white light. I just want to have a green light. So I'm going to zero out the green, or excuse me, I'm going to zero out the blue and the red and keep my green at a 5. All right, well, I want more than this. I want to have a total of 4 different indicators. It took me a while to pull all this out. You could build it again from scratch, but my suggestion would be to click on your conditional statement and duplicate the entire thing. And I'm going to do that 2 more times. One more. And now I can plug in my other numbers. Well, remember, 35 is the max. After that, you start having some issues. So let's continue with our ranges. So I ended with less than or equal to 14. So now I want to do greater than or equal to 15% and change this to 35. Well, let's give ourselves another indicator. It's safe, but it's getting louder. So I'm going to add some more lights to the 5x5 LED array. Here's the neat thing with color mixing. I went from green, now I want to go into yellow, like caution, like you're there, don't go any higher. This is where you want to be. When I turn on the red with the green, that's going to get me yellow. Okay, so that's my safest range. Now we're getting into the danger zone. So right now it ends at 35. I need to create a new range. I am going to say greater than or equal to, what do you think I'm going to put here? You said 36, you're right. And let's change this to 50. This is getting a little, this is definitely too loud for you to be listening to over a long period of time. So I'm going to give that a big old X. And let's have this become red. Turn my green off. And then finally, that leaves me, remember, I can only go up to 100. So I'm going to say greater than or equal to 51 and change this to 100. This is definitely way too loud. Absolutely shouldn't be listening to it at this point. So let's put that big X, but let's add to it. I'm going to do the sides here too. And if you know about brightness and stars, blues are our hottest, so let's make that blue. Let's review this real quick. So I have my loop, so it's going to keep running this program over and over again until I hit stop. And if the sound level is between 0 and 14%, I'm going to get a green light. If it's 15 to 35%, that's going to go to yellow. 36 to 50, I'm going to have a red light. And then lastly, when I've reached that 50% mark up to 100, it's going to be blue. All right. Now, I'm not going to have any screen output here. So I'll just bring this back up so you can see the data on the screen, but definitely pay attention to the code node. On your page, you can adjust the picture with the graphic if you want to have our pictures larger so you can see the code node a little bit better. All right, let's see how we did. Let me bring my music back. I'm going to start with it low. Okay. I have my earbud on here. Let's click start. All right, so you're seeing the green light and the dot. Let's turn it up. And you can see I got the volume all the way up. So that blue light, it's intermittent between red and blue. So I'm really crossing the line. And sitting here with my headphones on, I can hear the music coming through the earbud. So this is just a really neat way for you to take the application of understanding sound, how we measure it, and how it relates to your life in terms of safety for your ears. All right, let's stop that music. I'm going to do a quick screen change here. All right. Oops, got a little one hanging out here. All right, so you can actually, you'll get these if you use the bit.ly link. We have the investigation of sound levels full activity with objectives, directions, material list, procedures, and sample codes for both student and teacher. The student version also has a lot of questions and analysis related to sound and the programs they used. The big focus here in terms of coding is looking at these compound conditionals. By the time the students get into middle school, they should have worked with compound conditionals, and that's where we're seeing ranges having different things happen. All right, excellent. So now I am going to pass it on to Miss Barbara, and she's going to do energy flow coding with the temperature sensor.
Hi, folks. In just a second, I'm going to share my screen. And Glenn has put up that link for the coding and science activities that Heidi was referencing a minute ago. You'll also see the materials for the activity I'm about to go over, as well as Dan's in there. 1 second. I'm going to show my screen. And now you should see my screen. Okay. So the big picture for what I'm presenting today, we're going to use the temperature sensor to figure out, or students will use the temperature sensor to collect data and see what's happening with temperature, to learn what's heat flow doing in a liquid. Is heat going into the system? Is it leaving the system? Is it equal in and out? Is the system at equilibrium? So we're going to use code to interpret the information from a temperature sensor and then create an output, not only text output, but as Glenn and Heidi mentioned earlier, you can also have numeric output. So I'm going to show both of those in a moment. So this activity supports all 3 dimensions of the NGSS, and particularly an activity you might do in high school or middle school is an enzyme activity if you're talking about life science, or catalyst, you're talking about physical science. How does a catalyst or an enzyme affect the rate of a reaction? So we're going to take a commonly completed activity for biology or chemistry and apply sensor and code to it. So you'll see on this slide, I've listed the materials and safety instructions. So I've included this PowerPoint in the materials. So if you wanted to do this activity with your students, you could either print this out or project it up on the screen. I'm not going to keep this up very long because I'll just walk you through as I do the activity. So the material safety procedure, directions on everything you see me do will be up here in this presentation. And even questions that the students can answer at the end of the activity to see, do they really have the concept of what's happening with energy exchange in a system, as well as getting the coding activity out of something that's content-based. So now I'm going to switch my camera to a different camera. And give me 1 second, and you'll see my experiment set up. Okay, so the direct, you should, everybody see that?
Looks
okay.
Good.
So here's a temperature sensor, and I've got it in this hydrogen peroxide solution. This is a 3% solution that you get from the grocery store. And I've got 60 milliliters or 1/4 cup of that in there. And this temperature sensor has been sitting in there for a while, so I'd expect the temperature to be at the correct baseline level or at equilibrium. I'm going to add yeast, which is a biological catalyst or enzyme that will break down that hydrogen peroxide into water and oxygen. And the energy changes that occurred during this chemical reaction will be recorded by the sensor. So because we're going to be looking at sensor data, I'm going to open up SparkView now. And you should see SparkView. Now I'm going to turn on the temperature. Oops, let me go back a step. Cancel that. Okay, so I wanted to show you from the home screen, how do you open those files that we're going to be sharing with you? Because we are sharing these SparkLab files with you. So you would go to the Open Saved Experiment button here after you've downloaded the SparkLab, and wherever you downloaded that file, mine is on my desktop, find the file you downloaded and open it up through the Open Saved Experiment option. And so you'll see this pre-built file. And the procedure shows students how to build, or helps students build this first page, but we want to look at the code first. So let's go to the code, and then I'll talk about the display once we've got data. Okay, so now I've got my code split up into pieces here so that when we put it together, I can just explain where these things came from and what is each piece doing. So I am, like Heidi and Glenn, I'm going to be using a loop because we constantly want to keep measuring the temperature, comparing it to the previous average to see, is the temperature in the system going up or going down or is it staying the same? And then we're going to report out from the data. We're going to interpret that as, is energy entering the system? Is it leaving the system? Or is energy at equilibrium? So the first thing is I created a series of variables. So this is a new block, the one that looks a little purple and it says set first reading. I went to the variables tab, and a variable is just it's like a container where it stores a value or a number or a statement that, or calculation or any number of things that you need the computer program to remember, because you need to reference it maybe more than once, or you just need to store a value. You see I've got several variables that I've created using this create variable button. Now you can see that I've got first reading here a couple of times, I've got current reading there a few times. So because I keep using the same value, I've defined it one time and I can just use my variable storing that the first time I defined it up here. Okay, so that's what a variable is, and like Heidi and Glenn showed you, you could use the drop down to change to whatever variable you need after you've created the variables that you think you will need to use, and you can even rename them on the fly, and it will rename across all variables if you do make a change to one variable. Okay, so this first block here, I have set this variable to, I just want to figure out what is the temperature sensor reading at the moment. Okay, I want to know what the temperature is, but then I'm going to tell it to sleep. So there's a time block here, sleep, for 500 milliseconds. And I picked 500 milliseconds because my sample rate in SparkView, I'm collecting temperature data twice per second. That's what 2 Hertz is. So I want the sensor, I want to wait at least that same amount of time before I ask for the second reading from the sensor. So the reason why I have to put this time block in here is not only because I want to at least match the sample rate of my sensor, but also because, believe it or not, there's 2 kinds of time when you're running sensors with SparkView. You've got the computer time, the speed at which the program's running, and you've also got SparkView time that is related to the sensor's perspective of time. So you have to put this sleep block in when you're in a scenario like mine where you're constantly referring to the sensor and you need to pause before you get the next value. So this first block, I'm reading the temperature once. The second reading, I've called this second reading, so I get a second value for temperature after another sleep block. And now I have 3 temperature readings, and I want to take the average of those 3 temperature readings. So now I created a variable called average, and I'm going to use math. I went to that same block that that Heidi and Glenn used before, math, but I used the plus function here, and I changed plus to divide to get average. You total the values and you divide by the number of values that you're working with. So I've got 3 temperature readings. I'm going to divide the total by 3, and the way that I total up these temperature values, that's this block here. I've simply taken the same type of block and I've added the first, second, and third reading together to get a grand total of all first 3 sensor readings. And when I divide by 3, I've got an average. Now, you might be thinking, if you're a little advanced or you've got coding experience, you might realize that this could be a function. So if you're interested in functions, you could look over on this tab, and this is the function you would use. I'm not going to go over that right now because we're a little short on time, but this is an opportunity for a function. So now the reason why that's a function is because it does a thing. It has a task, and the task is find the average. Okay, so all of this code just finds the average of the first 3 readings of the sensor every 500 milliseconds or half second. So now that I've got an average, I can display it in a numeric output or as a digits display called rolling average, which we'll see once I start the program. So I'm going to display the average as a digit display, but I'm not done yet because I need to make a comparison of what happens to how is the temperature right now, how does that compare to the average temperature from before to know whether it's increasing or decreasing. So in order to do that, now I need to find what's the temperature right now. So here's my 4th variable or 5th variable now. what's the current temperature? Here's my logic statement, and Glenn showed before the else statements. My first condition is look at the current temperature sensor reading. If it's greater than or equal to whatever we calculated for the average, plus 0.02, and I'll explain why I put this piece in there in just a moment. If it's greater than or equal to the average, then I want to display a message that says liquid's absorbing energy. So energy is going into that liquid. Unless or otherwise, if the current temperature sensor reading is less than the average, minus 0.02, then I wanted to say that the liquid is losing energy. Energy is leaving that liquid system. Okay, and let me explain now why I put these 0.02 values plus and minus here. I wanted to create a range like Heidi did, but the range that I want to create is plus or minus 0.02 from the average. So because I would consider plus or minus 0.02 from the average, to me that's like not hardly a temperature change at all. That could be background noise, that could just be this sensor error, that could just be random variation. So I would want that to define that range so I can say that energy is really not changing. So the liquid's probably at or near equilibrium, or it's approaching equilibrium. And that's why I've added these numbers. So that also means that the average in this block is different from the reported average in this block, because this is higher than, a little bit higher than the average, and this one is a little bit lower than the average. And now I've got the complete program, and I'm going to just drop this entire block into my loop. And let's take a look at what that looks like in SparkView. So I'm going to close the Blockly view, and I need to connect my temperature sensor. So here's how you connect a temperature sensor from within a lab that you've opened. You can go to the top right and click the Bluetooth button. I'm going to turn on my sensor. And there it is, and I'm going to connect it. And I'm done. And now I'm going to start collecting data. So you see that in the graph, that is my live sensor reading. So it's directly reading from the sensor. But the top right, this is the rolling average, calculated average. And on the bottom, I have a message that says the liquid is at or near equilibrium, which is great because I know this is my baseline. And for a moment, it went to absorbing energy because the average, I guess, went a little higher. But now I'm going to add the catalyst into the system, and we're going to watch what happens with temperature. Give a little stir. Ideally, you'd have a magnetic stir on here. And now that its temperature is increasing as the reaction goes, this is an exothermic reaction, and it reports that the liquid is absorbing energy. It's getting warm, and I should be able to feel it. And yeah, it feels like it's getting warm. For a moment, it said at or near equilibrium, but it's definitely increasing right now. So it's absorbing. That's going to keep going hotter. So I'm just in the interest of time, I'm going to pull this out so that you can see what would happen when it stops warming up. As it goes flat, it went towards equilibrium and instantly starts going down. Now the message says it's losing energy. So you can see how this program works. It helps students help you understand, or help you see if students understand not only what's happening with energy as temperature changes, but also can they interpret it into a statement of what's actually happening in this program. Now I'm going to hit stop. You might have been looking at this code and been thinking, wow, I don't want just 3 values for an average. I wish I could do more than that. And absolutely you could. Like Heidi mentioned, there's more than one way to do code. So a more advanced coder might use something like this, which is a list. And what the list does is allows you can increase the sample rate, go faster, get more values, and get a better average to get a more smooth data collection and better statistics that way. So take a look at that if you're interested. And one more thing that you can do with that SparkView file that I shared, you'll notice in the resources that I've shared, when you go to the energy flow folder, I've shared 4 different Spark Labs. 2 of them, one of them is the beginner version, which looks like this. One of them is the advanced, which has the list in it. And then there's 2 more that say, in the file name, they'll say scrambled, because what I did there is I pulled apart the code and just shuffled around the blocks. So an activity you could do with students is to take the shared code and mix it up and see if they can put it in the right order. If you have beginner coders, or if you want them to learn a little bit more advanced techniques like lists, and they can figure out from that. Okay, Okay, so if,
Great.
let me go back to my presentation. I'm gonna go on back to share with Glenn.
All
I'm
right.
sorry, Dan,
Yeah. Thanks,
and
Barbara.
stop
So
sharing my screen.
Barbara showed us some more advanced capabilities of Blockly coding and how you can have numerical outputs. Dan's going to extend that over into generating mathematical models. We have formally 5 minutes left, and Dan's going to jump in here and quickly present that. We do have some nice resources to leave you with. So after Dan's done presenting, I am going to jump back to some slides and share those resources. We understand your time may be constrained though, so watch the recording if you need to depart at exactly 1/2 the hour. And we thank you for attending. So resources after Dan, but Dan, go ahead, take over.
Okay. I think I'm showing my slides here now. Is that okay? Great. So this is a simple experiment, 2 different ways of doing it. We have a beaded chain on a pulley, and we're measuring the rotational speed of the edge of the pulley, which is also the speed of the chain, using a photo gate. So if you have a photo gate, you can do this experiment. It's a little awkward because you have to orient the pulley vertically so the chain doesn't hit it. It's too thick to go into the gap here. So another way to do it that I'm going to focus on is using the rotary motion sensor. And so I have a different, thicker chain around it. And the idea is the chain is slightly off balance, or it can be way off balance, and it will move. And the motion is non-constant acceleration, which is usually maybe beyond what you would do in a high school physics class. But with coding, you can model it. And so the idea here is to have the students model what the behavior is going to be, and then actually measure it and compare their model to the measurements. There is a surprising thing that happens, though. They may not notice here, it's in slow motion. Toward the end, the chain does not stay on. And that's a whole other project that I'll work on at some point. Here it is with the thicker chain. And so the students may end up investigating that. So the idea is we have the chain over the pulley, mass M, length L, and there's some initial length on, in this case, the right side. It could be the left side, doesn't really matter. And we're ignoring the pulley mass and friction. And we're also going to ignore the little bit of chain here on top of the pulley. You can include that. That'd be a good extension. So a free body diagram of the chain on the left and the chain on the right, well, we need to work out the weights here. The idea is to get the net force, so it's a simple algorithm. Find the net force on the chain, and the change in momentum is the net force times a small amount of time. And so if I know the change in momentum, I can solve for what the velocity is, and then the position, assuming in that small amount of time, the net force doesn't change. And then I can increment time and repeat. And so it looks something like this. That's what sort of the code looks like. Normally we'd have a V naught here, but in the code you can do it that way. So the students try and figure out what the weight is on each side. And so it is the weight of the chain that's just hanging there, the fraction of the chain times the total mass, plus this extra little bit that has moved over to the right side. And so if this extra little bit moved to the right side, it's missing over here on the left side. So if I add all these forces together, well, the tensions are an internal force. They won't affect things. And now I've got a little bit of algebra to do and simplify that. And it simplifies down to this. So this would be the net force I put into here, and you'll see that in my code. If you wanted to simplify it, well, you can have the chain draped equally on either side and just give it a tiny little start. And so if you do that, X naught is equal to half the length. And so this term here is just half the mass. And this term here is just half the mass. And you end up with this real simple relationship of the net force to position X. And that's what I'm going to show is doing this simplification here. And you can sort of test out the answer when X is L/2, when it's leaving the pulley, the net force is the weight. So this is the Blockley code. So it's just a loop, incrementing time as you go through it. I'm not showing you me creating the code because most of the time is creating the variables and initializing them. But we repeat while this is a statement, while the chain is on the pulley, so it'll stop on its own. So let's take a quick look here, very quick, because this is a short experiment. So on the top here is the output from the code. I'm going to graph velocity versus position. And then below that is the actual measurement. And I've got it, you can sort of see it over my shoulder. I have a second camera view. Let's see if we can find that. There we go. So I can just drape the chain over. And usually you can get it to balance. It's a little tricky. Kind of has a mind of its own sometimes. You can just hold it with your finger if it's acting up. Then I'll hit start or record on Capstone. This would work with SparkView. And just give it a little start here. And you can see the actual data was collected a lot faster than the code. You can adjust the time step to alter that, but the code's still pretty fast. And you can see it went to 0.5, so I got a nice straight line. Well, what's all this? Well, this is when the chain came off, so we're not really comparing that part. So let's bring it out to here. And you can see I have a nice straight line for the part while the chain is on the pulley. So the relationship between velocity and position is linear, and you can get the slope. And so this is a slope of the actual collected data, and it's 4.15, and then the code output a slope of 4.4. You can solve this theoretically, and I included that in the slides, and it's 4.43. And so it works really well. You can also pick off individual points and compare them. Here's the code saying that at position 0.15, the speed should be 0.66, and in actuality at 0.15, it was 0.62. So pretty good. There's some friction and some rotational inertia. And so that was, that Capstone file is included. Again, I mentioned the theoretical slope. You can solve for that. That does require calculus, but you can see no calculus was used in the making of this presentation. I have a lab written up for this with a student and a teacher version, and I would bet any questions that you would be having right now are answered in that, but I'm also always willing to take your questions. And I have some references as well that are in my slides. They're all up there. So I got through, I went 3 minutes over. Sorry, I apologize. It was all my fault.
Fantastic. Thanks so much, Dan. So let me switch back to some of those resources. Again, we hope among these 4 activities with a wide variety of levels of complexity, you find something that would be useful for you and your students to do an hour of code next week. Let me share some tips about hour of code. And as a reminder, among the resources to help you are the recording that you'll get of this session and all the files. That link is in the chat right now if you want to go to it live. So some tips for hour of code. I think one of the biggest problems with code is a lot of you came in, 57%, it's new or mostly new to you. Hopefully you learned some things today, get some time to explore, but jump in, even if you don't know everything yourself. You will find, as I do, I go home and have some coding questions, and my 14-year-old son is the best person to ask those, and he fills me in. So look to students, school colleagues, community resources, and this webinar's resources for help, but do jump in. Making coding mistakes and troubleshooting them is part of being a programmer. So it's low low risk. You get some code wrong, it just doesn't work, unlike the physical things in the world. So it's a great place to troubleshoot. When feasible, let your students' interests guide their explorations. Coding for only an hour might limit that, but do it if you can, and adapt to your students' levels of sophistication with coding. And it's quite possible, since coding isn't included in a lot of curricula, that their levels will be widely variable. Here are some things we came up with for some ideas. Group students together with diverse experience levels to help each other out. For advanced students, have them do it from scratch, open-ended activities, do extensions to fill that time. If you have students who need some more help, you might provide partially completed files. We saw Barbara have kind of a jigsaw puzzle that could be put together. That's one idea. You could complete the code except for variable values and have students determine what the appropriate variable values are based on sensor measurements. You could have broken code and ask students to analyze the fix, and celebrate students' achievements and have fun. There are a lot more tips at Hour of Code, and even a certificate generator if you want to provide that for your students after their hour of code. One thing that is not even off the presses yet, but something I only saw for the first time yesterday, we went through a lot of features of code today, and the recording will hopefully help you with those. But if you have more questions and need to see a wider range of examples, there's a great resource that we're going to provide for you in our shared folder here. It's a 50-page PDF of all the blocks in Blockly coding, described block by block and with some great examples. For example, Barbara introduced us to a great way to handle the time with a delay. If you want to even get more sophisticated, instead of having a sleep, which has the code not executing, page 50 has a great example, number 4 there, on performing synchronous activities. So lots of great resources in there, both block descriptions and block examples for you or your students to use during the hour of code. We have some additional resources. The thing to remember right now, though, is just this Dropbox link, which has these slides with additional links. But we encourage you to ask questions, look at our website, our YouTube videos, join us for future webinars, and our emails are all here. So we'll formally wrap it up. I'll leave this slide up, but we ask you to ask any questions at this point in chat. And if you need to leave right now, close Go to Training, and there'll be a brief survey that comes up. We'd appreciate your 2 minutes to give us feedback about this session and our future offerings. So I'll go back to this additional resources slide, and maybe my colleagues and I can turn on our cameras here and try to address any questions that you have in the chat. Otherwise, we want to thank you so much for joining us today. It's been fun. We hope you have a good experience with the Hour of Code and your students. But we'll be sticking around here for any questions that you have for us in the chat. So fire away. Thanks, Freddie. Thanks for coming, Heather.